All right, finishing up our notes from section 6.5. We had looked yesterday at solving some radical equations. All right, trying to undo either a radical symbol or a rational exponent. We are going to look at some different ones today. So just take a quick glance at I think we have 4 examples today. What's different about them from what we did yesterday? There's variables on both sides. What else? Look at the last 2 examples we're going to do. There's multiple radicals. Okay, we don't just have a single square root that we're trying to undo, we have a couple different ones. Okay, so we're going to look at our techniques for doing that today. The one thing I do want to remind you of is checking your solutions. Yesterday, most of the things you did should have worked, right? Today, that's not going to be the case. In many of these, we're going to get 2 answers. Sometimes they both work, sometimes only one works. It's possible neither of them work. You have to check them. Okay? All right, so our first example says, what is the solution of the square root of x plus 7 minus 5 equaling x? Just like yesterday, we want to isolate the radical piece. Okay, so I need to move this -5 to the other side. How am I going to do that? Okay, so now we end up with the square root of x plus 7 equals x plus 5. Yesterday, this x would have been a number that we could have just added 5 to and just had a plain number there. Okay, now we have an expression x plus 5. And our next step to undo our square root was to square. Well, now we have an expression that we have to square. On the left side, the square and the square root will cancel each other out. What happens on the right-hand side? We are taking x plus 5 times x plus 5, right? So if you need to write that out twice and FOIL it, you can. If you remember the pattern for squaring a binomial, we square the first term, so x gets squared. We multiply the 2 pieces together, so x times a 5 is 5x, and we double that, because your insides and outsides, when you FOIL that out, would be the same 5x. So doubling gets us 10x, and then we square the 5. Okay? Again, if you didn't remember that, write it out twice and FOIL it out. Okay? We now have a quadratic equation to solve. There's an x squared in there. We want to bring everything to one side so that we have a 0 on one end. So I'm going to subtract the x and the 7 over to this side. That leaves me x squared plus 9x plus 18. Again, it's a quadratic. It's equal to 0. How do we solve that? We need to factor it. Yep. All right, our x squared, we're going to break into x times x. What numbers will multiply to be 18 and add up to 9? All right, I heard 6 and 3. That means our solutions are what? Yes. X could be -6 or x could be -3. Now again, we have to check those. And remember, you're always plugging them back into the original equation. All right. So we are going to put an x there and there. There's 2 places where we see an x in our equation. Both of them get replaced with the same number. Okay. So let's try the -6 first. We've got the square root of -6 plus 7 minus a 5. Now make sure that 5 is not inside your square root symbol. And it's supposed to equal the same x value of -6. All right, -6 plus 7 is 1. Square rooting is 1. Does 1 minus 5 get us a -6? No. All right, gets us a -4. That means the -6 is an extraneous solution. What I want to see you do is cross it out. Do not erase it. Do not scribble it out so much that I can't read it. I want to see that you knew there was a -6 as a possible solution, that you checked it and it doesn't work. Your other option is to say this is extraneous. instead of crossing it out. Okay? Checking the -3. We have the square root of -3 plus 7 minus a 5, and we're supposed to end up with a -3. We get 4 here inside the square root. Square rooting is 2. Does 2 minus 5 give us -3? Okay, so that one works. That would be my only solution. Questions on that process? Okay, I'm going to pause the recording. I want you guys at your table to try this next one. All right. First step, did you move the 3 to the other side? Okay, so you have the square root of 5x minus 1 equaling x minus 3. What did you do next? Okay. Squaring both sides gets me 5x minus 1 on the left. What do we end up with on the right? Good. All right, bringing everything to one side, I'm going to subtract the 5x over. I'm going to add a 1 over. So I have nothing on the left side anymore. I have an x squared minus 11x plus 10. Okay, factoring that, what do we get? Okay, so possible answers, x could be 1 or x could be 10. All right, checking them. If we try the 1 first, we have 5 times 1 minus 1 under our square root plus 3 equals 1. We have 5 minus 1, that's 4. Square rooted is 2. Is 2 plus 3 get us a 1? Okay, that's extraneous. Trying the 10. 5 times 10 minus 1 plus 3 is supposed to give us a 10. We have 50 minus 1, 49. Square rooted is 7. Does 7 plus 3 give us 10? All right, so that one works. Okay, are we okay with that type? All right, the last two that we're going to look at are the ones that have multiple radicals in them. It says if an equation contains two radical expressions or two terms with rational exponents, isolate one of the radicals or one of our terms, then eliminate it, then isolate the more complicated one first. Okay? So of the two that we have, it's best to try to get rid of the more complicated one right away than to keep that complicated expression in the process all the way till the end. Okay? So if you look at the example we have here, we have a square root of 2x plus 1 and we have a square root of just an x. Which one looks more complicated? The 2x plus 1. So we're going to start by isolating that one. Okay? Once we get that more complicated one isolated and cleaned up, then we can take the remaining equation. It will still have a radical in it. Then we can isolate that one and clean that one up. Okay, so we're kind of going through the process twice. All right, so isolating the square root of 2x plus 1. I'm going to add the square root of x to the other side. Be very clear when you bring that square root of x to the other side that that 1 that was already there is not inside the radical. Okay, make sure your radical symbol ends right after the x. Now, to undo a square root, we square both sides. The more complicated one, we are getting it cleaned up into being just a 2x plus 1. On the other side, remember that pattern. When we take a binomial and square it, you either write it out twice in FOIL, or you remember the pattern. The pattern says take the first term and square it. What happens when we take the square root of x and square it? We get an x. Okay? Then it says multiply these two together and double it. So 1 times the square root of x is the square root of x. Doubled would be 2 square roots of x. Okay? Then we take the last term, in this case a 1, and square it. 1 times 1 is still 1. Okay, we still have a radical in there, yes? We want to isolate that. So I'm going to get rid of this x, bring it to the other side, and I'm going to get rid of this 1. This side now just has the 2 root x piece on it. The other side we end up with just a plain x. Okay? At this point, if you are able to get that 2 away from the square root of x without creating fractions, I would do it. In other words, if this problem had been 4x equals 2 root x, I'd go ahead and divide out the 2 right away. Okay? Get that piece away from the square root of x and truly isolate that. In this case, when we try to divide the 2 to the other side, we'd end up with a 1/2 x. We then have to square both sides. Now we're squaring a fraction. We then have to get everything to one side and FOIL, or in factor. We're dealing with fractions. So it's not really going to help me any to create fractions. Okay? But if you can get rid of that, you should. Okay? If you can't, we can still go through and square both sides to undo that square root symbol. But you have to be careful because on the right-hand side here, both the 2 and the square root of x are getting squared. So the 2 gets squared and becomes a 4. The square root of x gets squared and becomes an x. Okay? On this side, we end up with an x squared. The common mistake students make here is say, I'm going to divide out an x. You can't do that. You're dividing out some of your possible solutions. Okay? What we can do, because it is quadratic, is the same thing we did on the last couple examples. Get everything to one side and then factor. How do we factor it when there is no constant? We take out an x, right? There's a GCF in that. We can factor an x out. We end up with x minus 4. So what are my possible solutions? 0 or 4, okay? Now, let's go back and check those. If we check the 0, okay, I dumped a 0 in for my x's. 2 times 0 is 0, plus 1 is 1. Square rooting is 1. The square root of 0 is 0. Does it work? Okay, so 0 works. Checking the 4. We have 2 times 4 plus 1 minus the square root of 4, and we're supposed to get 1 for an answer. We've got 8 plus 1, that's 9. Square root it is 3. Square root of 4 is 2. Does it work? So here's a case where both of our solutions work. All right, our last one. Which one is the more complicated radical? Yes. So we're going to bring this to the other side. All right. We end up with the square root of 5x plus 4. I'm going to add the square root of x to the other side. So now it's a positive root x plus the 4 that was already over there. Okay. Our next step, square both sides. Go ahead and take a minute to square both sides. All right, checking. You should have 5x plus 4 equals, on this side we square the square root of x and get x. We multiply them together and double it, so you should have an 8 root x, and we square the 4. Okay? Getting what we can to the other side. So we're trying to isolate that. I'm going to subtract an x over. I'm going to subtract the 16 over. We now have 4x minus 12 equaling 8 root x. Okay. Can I divide both sides by 8 without getting a fraction? No. But can I divide out something?
Yes.
What could I divide from both sides? a 4. And that's going to make your factoring and your squaring a lot easier. Okay? So we're going to divide both sides by 4. On the left side, what do we get? X minus 3. On the right side, 2 root x. And now it's similar to the last one we just did. Okay? We can square both sides. Okay, I'm going to pause the recording. Go ahead and finish this one up. All right. So squaring x minus 3, you should have x squared minus 6x plus 9. Squaring the other side, you should have gotten 4x. Subtracting the 4x to the other side gets us that. Factoring. So solutions could be a 9 or a 1. Yes? All right. Checking them. All right. We've got the square root of 5 times 9 plus 4 minus the square root of 9 equaling 4. Checking the other one. 5 times 1 plus 4 minus the square root of 1 equaling 4. Okay. 5 times 9? 45 plus 4. 49. Square root of 49 is 7. Square root of 9 is 3. Does it work? Okay. Checking this one. 5 times 1 is 5 plus 4 is 9. Square rooted is 3. Square root of 1? Does it work? No. All right. So the only one that worked was the 9. That would be my solution. That one's extraneous. Okay. All right. So there is your homework assignment. You have a lot of work time today. Make good use of it.